Hello everyone, in the last session we have completed the capacitor. Now we are going to start one of the very important chapter of physics, that is or you can say one of the new part of physics, that is a magnetism, in which we will discuss two types of things basically. The first thing is revolve about the discussion of magnetic field, and second thing is the force due to this magnetic field. The first thing we will calculate the magnetic field due to the different geometries like the electrostats, and then we will go for the calculation of force, just opposite to the electrostatic. And in electrostatic, first we discuss about the force and then we move to the magnetic, then we move for the field. But here we will first calculate the field and then we will move toward the force, correct? So let us start. So our first, before starting a magnetism, the prerequisite is that you should know about cross product, okay? And I have covered the cross product properly in the vectors. You can go and see my lecture series of vectors. But just as I am starting a new chapter, for introduction sense of, I am going to give you the idea how to do the cross product, how to find the direction of the cross product, not the exact method completely. Just I am going to give you the tips or tricks, you can say, to calculate the cross product. Okay, cross product, because without that you can't solve this any question in this chapter. Okay, you should know how to calculate the cross product. So let us do some practice with me. Suppose basically cross product means suppose C vector is equal to A vector cross B vector. So what my question is simply one, I have only one question: what is the direction, how to find the direction of C? That is my question, direction of C. You should know how to calculate the direction of C. That is the only question. So let us consider C. Remember, cross means, what do you mean by cross? Cross means inside the plane. Inside the plane means if this is my plane, then I am talking about inside. Okay, inside the plane. And dot means, if there is a dot, then what does it means? It means outside the plane. These are the few things which is required in the starting of the chapter, so you should know about all these things, correct? Inside the plane and outside the plane. Second thing, how to find the cross product. So you should always use for finding cross product, always use the right hand. Never use left hand, because a lot of people confuse regarding what hand I have to use. Then what you have to do, you have to keep your, now let us learn with the example that what we have to do to find the direction. Okay, remember these points, by using these points only we will find the direction. So let us take one examples. Suppose there is a vector A, this is my vector A, and vector B is like this. You have to tell me the direction of A cross B. What will be the direction of A cross B? First I am telling you, always take your right hand. Okay, first we have to find A cross B. So put your hand in the direction of A. First rule is put your hand in the direction of A. So this is the direction of A, or this is the direction of A. Obviously dot means outside, so you have to put your hand in the outside the direction of A. So this is my direction of A. Then what you have to do, after that you have to curl in the direction of B. So this is my A is outside, curl in the direction of B. So this thumb will give the direction of C. So it is like this. This means my C vector will be like this. Are you getting my point? This is how you have to do. Listen again. What you have to do? Listen again. First you have to keep your hand, or you can say right hand, in the direction of A vector. Okay, then curl your hand in the direction of B. Then the direction of C will give the direction of thumb will give the direction of C vector. Clear? Just keep your first right hand in the direction of A. So A is outward, so I have keep outward. Okay, this is my A vector. Then curl in the direction of B. See, B is in this direction, correct? In this direction. Right to first, A means outside, B is in this direction. So just curl your hand in the direction of B. Curl it. What is the direction of thumb? The direction of thumb is upward, like this. You are getting like this. So that means my C vector will be like this, correct? Let us practice some more. So just suppose this is my A vector cross and this is B vector. Tell me what is the direction of C. Just use your right hand and tell me what is the direction of C. What is the direction of C? Now see, A is inside A. Then what you have to do? You have to curl in the direction of B. So some people will curl like this. You have to not break your hand. Okay. A vector is this. You have to curl in direction of B. Na? So rotate like this. Okay. Curl in the direction of B. You are getting the thumb in this direction. So this is my direction of C. Simple. Similarly, let's take one more example. Suppose this is my B vector and this is my A vector. Then what is the direction of C? What is the direction of C? Can you tell me? What is the direction C? What is the rule? First put your hand in the direction of A. Then curl your finger toward the direction of B. See, B is inside, so curl inside. What is the thumb direction in this direction? So this is my direction of C. Simple. Next example. Suppose this is B vector and this is A vector. Then what is the direction of C? What is the rule? First keep your hand in the direction of A. Okay. Then curl toward the direction of B. B is outside or inside? It is outside. So just curl like this. Curl outside. Downward. It will be like this. Let me draw it properly. So you will get like this. This is my C vector. Clear? So this is how you find the cross product, direction of the cross product vector. Why it is important? Because our first law is based on this only. If you don't know how to use your hand, you can't, this chapter will be gone from your hand. This is a very easy chapter, but you should know how to find the direction. Clear? Now it is clear. This is a basic concept which I want to tell you. Clear? Okay. Now how the magnetism basically started? Basically what scientist has did. Scientist had first taken the magnet. Let me tell you one story. It is a type of story you should know. First, what the scientist has did, scientist has taken a magnet. They have taken a magnet and they bring two magnets. We know that when basically from class 10th you have learned about the magnets. Suppose if I have a two magnet, okay. If I bring north pole together, they will repel each other. If I bring south pole together, they will repel each other. North and south will attract, south and north will attract. That you know, okay. So basically, what is that like basically what we have learned that whenever we bring a magnet, they have some force of attraction and repulsion will be something will be there, okay, that we know by the class 10th strategy. But the thing is that what is the reason of that force? My question is, what is the reason of that force? There must be some reason. Like in the electrostat we have seen, whenever we are bringing two charges, they will either attract or either they will repel. So my question is that what is the reason for that attraction and repulsion? We have got a reason, that is electric field. Similarly here also, what is the reason? That is reason is a magnetic field. That reason is a magnetic field. But what scientists have discovered, they have seen, suppose I have a what they have done. This is a basically what they have done. They have taken a some wire. Okay. Suppose this wire has a current I. Okay. Suppose this wire has a some current I. What they have observed in the experimentally what they have observed, they have observed that, see, first you tell me whether what is the total charge on that wire. This wire is what? This wire is charge or neutral? Obviously it is a neutral. Okay, there is a no charge now. The wire is neutral only because it is it has a total number of electrons and protons, both are equal. Current is flowing, it doesn't mean that it is charged. It have a the total charge is zero only, correct? That total charge is zero only. Okay, it is a neutral. What they have seen, first they have keep a charge here, correct? Then they have observed that due to this wire, there will be any electrostatic force on this charge q. My question is that due to this wire, there will be any electrostatic force on the charge q. What they have observed? Observation I am writing. First you tell me, will there be any electrostatic force on the charge q? Will charge q experience any electrostatics force? Will charge q experience any electrostatic force? Answer is no. Why? Answer is no, because it is neutral, na? Because the conducting wire is neutral. And we know that whenever we are calculating a force on any charge, we have to multiply that charge with the electric field of the other charges. Is there is any electric field due to this conducting wire? Answer is no. Why? Because it is a neutral. There will be no electric field, obviously. So that means there is a no electric force. Okay, no problem. Then what they have did, by some externally something will happen. They have given a very small velocity to this charge, that is v. They have given a very small velocity to the charge, that is v. In reality, if there is a no electric force, then what is the direction of this charge? What should be the direction of this charge? If there is a no electric force, then what should be the direction of this charge? The direction of this charge should be like this, correct? Straight line. This should be the direction. Are you getting my point? The direction of this charge should be a straight line, because there is a no force, na? So it should move in that straight line. There will be no force, so it should move in the straight line, correct? But what has been observed? What has been observed? It is observed that the direction of the motion of the charged particle is like this. This is observed. This has been observed. Okay, this has been observed. This is a second observation they have made. So from there, what they have calculated, what they have observed, like what they have got idea. See, it should go a straight line, but when we have applied a very small velocity, now it is deviated from its straight line path. That means someone has applied a force on this, correct? Now my question is that from where this force has been came. So they observed that when a small velocity is given to the charge, then move in path 2. This is my path 2. Correct? This is my path 2, which is only possible when some F is applied, and this force is called as, and they called as, this force is called as magnetic force, which is due to the magnetic field of the current carrying conductor. So this is the experimental observation they have did. Experimental observation. This is the experimental observation has been performed, and they have observed this thing. After this observation, they have given a first law. So from there they got idea. Basically, lot of other things are also done. They directly don't go to a conclusion that this is a magnetic field. But yeah, this is what they have performed, and finally they went to a law that is called as a very famous law. And what is this law say? That this law is called as a Biosavart, maybe I will wrong in the spelling. Biosavart's law. See, for a law there is no proof. Always remember that law cannot be proven. Okay. What is a Biosavart's law? Biosavart's law simply state that if suppose there is a current conducting wire, see, no one going to ask you the law. You have to understand the statement and then you have to apply it. Basically, application is important for this law. What they have said, if there is any current carrying wire or current carrying conductor, okay, anything. If you take a small length of this, that is dl. Suppose the small length is dl, okay. And if you want to find the electric field at this point, okay, suppose the point is this, and suppose it make an angle theta, okay, this angle is theta, then the magnetic field at this point, the magnetic field vector at this point will be defined as, what is the formula? The formula is given as mu naught upon 4 pi into I dl vector cross r vector into mod of r vector whole cube. This is the, now why I am telling you that you should remember the cross product, because only by doing this cross product only you will get the direction of b vector. So if I ask you what is the direction of that b vector at this point, what is the direction of magnetic field at this point, can you tell me? What is the method? First keep your hand in the direction of dl. See, what will be the direction of dl? My question, first thing is, what is the direction of dl, sir? It is along the direction of current. This only those person can understand this chapter who has a better vectors. So if you don't understand vector, just go and see my vector lectures first. If you are not have a time to see the complete vector lecture, just go and see the cross product only, so that you can understand how to calculate the cross product at least, and then come to this lecture, because otherwise you won't able to solve a single question. It is along the direction of current, direction of correct. Now what is r vector? It is a position vector from the current carrying conductor to the point where we have to calculate the magnetic field. That is the two things are there. I can write it in the magnitude form also if you want. We can write it the magnitude value also. What is mod of dv vector is equal to mu naught into 4 pi into I dl r divided by r cube. So r will sine theta also. Okay, so this what you can write. So you can write like this, mu naught upon 4 pi I dl sine theta, sorry, I dl sine theta divided by r square. Now what is mu naught upon 4 pi? If you remember, it is a, in electrostatic it is called as a permittivity of free space. Here it is called as a permeability of free space. It is termed as a permeability of free space. Permeability of free space. Okay, and the value is given as 10 to the power minus 7. Correct. Mu naught upon 4 pi is equal to 10 to the 1 into 10 to the power minus 7. So if I ask you, oh sorry, one mistake is there. Yeah, so this value will be given as 4 pi into 10 to the power minus 7. Correct. So this is the thing. So it means it is also depend upon the medium. This force is also depend upon the medium. Yes or no? No, it depend upon the medium. That you can understand from here. No need to write this thing. So that is the thing. Clear? If this is a small dl vector, so what will be the direction at this point? Simply put the one direction, take your right hand, put in the direction of dl, Then after that, what you have to do? You have to curl toward the direction, toward R, dl cross R, that is inside. What is the direction? Is inside. So the magnetic field will be inside. Magnetic field will, at this point will be, it will be inside. See, dl cross R, inside. Or if you are not able to, there is another method also to find. This is a standard method, everywhere applicable. There is another short method I am telling you, short trick. What is a short trick? The short trick is very simple. Okay, what you have to do? See, every rule is applicable on the right hand only, that is, remember. Keep thumb sorry, keep the thumb in the direction of dl vector and palm in direction of R, then curl the palm you will get the direction of B. Means what you have to do? What is the rule? Are you able to understand what is the rule? Just keep your thumb in the direction of current, keep it like this, then put your palm in the direction of R, okay, like this, and then curl it. It is going inside, so the direction is inside. Simple rule. Okay, that is another rule you can apply if you want. Okay, that is a short method, but the ideal rule is very correct. Whenever you have to cross product, you have to do A cross B, or in the direction of, like what I have told you, that is the exact method. But if you want, you can apply this short trick. It is valid here only. Okay, if general case, it is not valid. Generally you have to go by this thing. Okay, clear? Any doubt? Anyone have a doubt in the law? This law is very important. No one was going to ask you what is the law. Just you have to remember this much point in the law. Okay, this much point you have to remember for applying it anywhere. Correct? Okay. Okay, so first case is wire. In electrostat also we have started with wire. Here also we are going to start with a wire. The derivation is exactly same. Okay, and this derivation is very important for JEE advanced point of view. Okay, and for NEET student, result is very much important. Okay, so suppose we have a wire. Okay, and the length of the wire as given. The length of the wire is given to you, that is L. Simply remember, let's basically what is given, this is the point. Suppose this is my point, I want to find the magnetic field at this point, and the current is like this, I, current is going like this, okay. And what we want to do is that we want to calculate the magnetic field. Clear? We want to calculate the magnetic field. So let us do the calculation. Okay. Okay. So this is via, suppose this angle is given as theta 1, this angle is given as theta 2, correct? Everything is given, and this distance is given as, suppose, d. This distance is d, and we have to find the magnetic field. What is our approach? See, first everything is, I'm going to be little fast because we have done all these things in the electrostats. Okay, so first step is take the small element, okay, from angle theta, go and take a small element d theta, correct, and from here, from y distance, you go and take a small element dy, correct. These all things we know. Any doubt? Okay, so what is the distance? This distance, suppose r. So we can say our small magnetic field dv. First tell me what is the direction of that small magnetic field. Inside, correct. This is my inside magnetic field will be inside, correct. Any doubt? Okay, so dv, let me write the dv. Dv is equal to what? Mu naught upon 4 pi into I, correct, into I into dl. What is dl? dl is dy, okay, correct, into r, basically into sine theta, or you can say into sine theta. What is the sine theta? Theta is the angle between the r vector and the dl vector. So you can see this is my dl vector, this is my r vector. So basically this angle is theta, this is 90, this is 90 minus theta, so this angle will be how much? 180, 90 minus theta, so 90 plus theta. Are you getting my point? This angle I am saying it will be 90 plus theta. Now you can think how it is 90 plus theta. So this will become sine of 90 plus theta, correct, divided by how much? R square. Now you know one thing, that is tan theta is equal to how much? That is y by d. Tan theta is equal to y by d. So y is equal to dy is equal to into d sec square theta into d theta, correct. Now put it everything here. This is mu naught upon 4 pi into what is sine 90 minus sine 90 plus theta is how much? Cos theta. What is r? R value, see, theta, this is theta, this is p, this is b, and this is r. So you can calculate the, basically you can calculate cos theta is equal to, that is d by r. So what is r? R is equal to d sec theta, correct. R is equal to d sec theta. You just put it here, you will get d square sec square. I am going little fast. Why I am going? Because I have covered all this thing earlier also. Sec square theta into dy is how much? D into sec square theta, then d theta. Sec square theta will cancel out. This will cancel out. I is here, so mu naught upon 4 pi into d into I. And what is the integration? Integration is from cos theta d theta. What is from where? Minus, sorry, from minus theta 2 to plus theta 1, correct. Just integrate this. You know all the logic. I because in electrostat we have covered everything. So the integration of cos theta is sin theta 1 plus sin theta 2. Okay, this is the answer. So basically what you have to remember, just I am giving you a conclusion. Conclusion is very simple. What is the conclusion you have to remember? If suppose there is a wire, okay, of finite length, and the current going is I, and suppose the distance is given as d, And in this case, the magnetic field is inside. And what is the value of this magnetic field? The magnetic field value will be given as mu naught upon 4 pi into I, sorry, 4 pi into I into d into sine theta 1 plus sine theta 2. And everything you know, what is theta 1, what is theta 2, this all we have discussed very properly in the electrostats. If you don't remember, just go and please revise your notes and everything, because this all things we have discussed very properly in the electrostats. And that is why I have taken so much time to complete one single chapter, electrostats. Why? That is why that chapter is of belong to 150 pages, because I have covered a lot of concept which is going to be used in this chapter, in that chapter only. So these things I am not going to repeat, otherwise the syllabus cannot be completed. So you have to remember this conclusion, and this is a formula. Theta 1, theta 2, how to take, you know. What is a d? D is a perpendicular distance from the wire to the point. This all things you know, okay. Everything, all the rules I am writing here, all the rules are same as electrostatics. Whatever the rules you know there, all the rules are applicable here also. So just remember this point, very important, very important for you. Clear? Any doubt till here, please tell me. No doubt. Completed? Okay, note it down. Completed? Okay, so this is the formula we got. So let me ask you for a few application of this. So let us take one example. Have you understand the formula? Okay, so let me ask you a simple question. I hope you will tell me, because this type of question we have done a lot in the electrostats. So suppose this is my wire, and suppose this is the point, correct, and suppose this distance is a, correct, this angle is suppose 30 degree, correct, and suppose this angle is 60 degree, correct. The current is going as 5 ampere. My question is very simple. At this point is P. I want to know the what is the magnetic field at point P. See, don't tell me the calculation, you just tell me what is the value of theta 1, theta 2 and D. If you can tell me this value correctly, you can get the value, and put the value, you will get the correct answer. That I don't want to know. I want to know theta 1, theta 2, theta D. Simple, you tell me this value. These three value is only important for me. No other things are not important for me. Whether you are telling or not telling, that is not required. I just want these three values. If you are able to tell me these three values, just write in your copy. Till I am writing the new question, another question, you just noted down these values in your copy. So what is the value of theta 1, theta 2, theta 3? Because all these things we have discussed very detailed. All these types of question we have solved. Clear? Suppose at point, this is a point P, at this point, and this distance is A, and this angle is 30 degree. You have to find the magnetic field. The current is 2 ampere. Again, my same question here is, you have to tell me theta 1, theta 2 and D. This is the three values you have to tell me for this question. Okay. I know you can apply the formula. Just first tell me these three values. That is only the thing I am interested of. Rest of thing I don't require. Just tell me the value. What is the value you will do? This is example number 3. Suppose this current is I. This is a square of side is A. Draw it properly. Suppose this is my center. I want to know what is the magnetic field at the center. These are his example. Clear? So I hope you have completed. So can you tell me what is the value of theta 1 and here? What is the value of theta 1? Theta 1, how you will take? It will be at the end. See, what is the rule? You have to take theta 1 and theta 2 from the perpendicular distance point to the end of the wire. That is a simple rule. So first you tell me what is a perpendicular distance. Is this is a perpendicular distance? Answer is no. So this is a perpendicular. You just extend it. What is the rule? Just extend this point wire. The perpendicular distance is this. So it is a, then a cos theta. So what is the perpendicular distance? A cos theta, that is cos 30, correct? That is the rule. So this value will be how much? Cos 30 is root 3 by 2. So a root 3 by 2, first thing. Second, what is theta 1? Theta 1 is an angle which is taken from the perpendicular distance point, okay, to the end of the wire. So just tell me what is the value of this if I take from this point to at this point, at this wire. If this point to from this point means the point is now here and I am measuring the theta 1. So this is 30 plus 60, so it will become 90 degree, correct? Many of you have filled 60 degree, that is wrong. From here you have to take the angle. Now what is theta 2? Theta 2 is the point from perpendicular distance you have to take the angle, correct? This is my distance, this is my point. From here I have to take the angle at this point. So angle is 30 degree, but it is plus 30 or minus 30. My question is, it is plus 30. This thing we have solved, okay? If you are not able to do this, that means you have not covered or you have not revised. Go and do the revision of these things, okay? This all things we have covered. So what is my theta 1? Theta 1 is plus, theta 2 is plus 30 or minus 30. If you remember, I told you in the formula, same rule. In the formula, we are applying minus theta 2 here because we have considerated the negative sign. So here if I am telling, because why we have, because they both are in anti-clockwise opposite direction, correct? We know this. So here this theta 2 is in opposite direction or a same direction. It is in the same direction, correct? It is in the same direction. So we will write it as minus theta, okay, minus 30 degree. If you are not able to understand, that means you haven't studied the electrostats. Go and revise the electrostats, this formula. Just revise where I have tell the proper method, or you can go and watch that lecture, particular lecture. That is, I think it is a lecture number 2 or 3 maybe. So you can go and watch and then you will come and understand, okay, because these all things we have covered. Similarly here also, who are regular, they can understand these all things, okay? So for this, first we have to calculate the perpendicular distance. First I will extend this, and how I will calculate? See, perpendicular distance will be this. Not this is not a perpendicular distance. Now how to calculate theta? See, this is 30 degree. This will be also 30 degree vertical opposite angle. So this is 90 degree, correct? So and this will be how much? This will be how much? This will be 60 degree. Are you getting my point? I want to calculate this point, this distance. This will be a. How will you calculate? See, this is a. I can say it is a cos 60 degree, correct? So my perpendicular distance is a cos 60 degree, which is equal to a by 2. Are you getting my point? So it is a cos 60 degree. Now what is theta 1? Theta 1 means from this point you have to calculate, okay, the angle. Now the one thing I haven't mentioned, let me tell you, this wire is going up to infinity, okay? So if I measure theta 1, if some wire is going up to infinity, what will be the theta 1? Theta 1, you know, that will be 90. This all things we have discussed, okay? So how it is 90? You go and revise this first, then you will understand. Those who are not able to understand, theta 1 will be 90, and theta 2, from this point you have to calculate the angle at this point, correct? Are you getting my point? So this angle will be how much? See, this angle will be 60, this angle will be how much? How much will be this angle? This angle will be 60. Sorry, this angle is 60, this angle is 90, so this angle is 60, but it is in the same direction, so I will write minus 60. I will write minus 60, correct? So this is how you will calculate theta 1, theta 2 and d. For this, what you have to do? See, first you have to, if you can treat it as a single wire, na? See, simple logic. There are 4 wires are there. I will calculate by 1 wire and just multiply it by 4, okay? Okay, simple thing that I will do. Because the direction by all the wires will be inside. See, I curl inside, I curl inside, I curl inside, I curl inside. All are coming inside only. So the net magnetic field will be B1 plus B2 plus B3 plus B4. That is the net magnetic field, and all are same only if you calculate. So what is my net BC? BC will be simply equal to B1 plus B2 because all the elements are identical now, so obviously they will be same, so it will be what, it is a 4 times of b1, correct. Now what is b1? I can calculate. See, b1 will be how much? This angle is how much? 45 degree. It is a square, so this is also 45 degree. Just put the value mu naught I upon 4 pi into what is the d? D is this distance. How you calculate this distance? This is a by 2. Okay. Now what is sin theta 1 plus sin theta 2? That is 1 by root 2 plus 1 by root 2. That is 2 by root 2. Correct. So what you will get? You will get how much? Mu naught I. See, 2 will cancel out. This will cancel out. You will get pi root 2 pi by a. Okay, correct. This is the value you will get. You just multiply it by 4. So what is the net value you will get? You will get 2 root 2 into mu naught I upon pi a, and the answer is inside. So this is the answer, simple for this case. So this is how you solve it, and you will understand. You should know. See, if you want able to understand, you have to go and revise how to take theta 1, theta 2, theta 3, sorry, theta 1, theta 2 and d, because I tell a proper method in the electrostat. You can go and watch the particular lecture. The lecture is lecture number 2 or 3, I guess, and there is a you can see that, and then you can understand. Clear? Any doubt? Okay, so I hope you enjoy this session. In the next session we will go for the further discussion. Till then, take care, and if you like it, if you enjoy it, then like it, share it and subscribe it. Thank you.